Assume test scores are normally distributed with a mean of 75 and a standard deviation of 7. Find the test score that represents the 90th percentile. That would be the test score where 90% of the test scores are below it, but 10% of the test scores are above it. Now it says normally distributed. That means we have that bell-shaped curve where the horizontal axis represents the test scores. The mean goes in the middle. That one has the highest probability of occurring. That was 75. So we're looking for the test score, the X value, that separates the bottom 90% of the data, which would be this area. We can represent that as 0.9. And that means this area would be 0.1, since the whole area under the curve is 1. All right, so we can find that X value using the calculator. You need a calculator with the distributions. I have a distribution button on this one right here. This is a TI-84. And when you press the distribution button, you have a bunch of distributions. You should have some that involve the normal distribution. Mine is at the top, and you want to go to where it says inverse norm. So this 90th percentile test score, I'm going to be using inverse norm in the calculator. The first thing you want to tell it is the area. In this case, I need to tell it the left-hand area. And then put a comma. And then you tell it the mean and the standard deviation. So this was the left area. This is the mean. And 7 is the standard deviation. All right, so I'm going to plug this in the calculator. 0.9, comma 75, comma 7. And I get approximately 84. So 84 is the test score that represents the 90th percentile, meaning that 90% of the people score below 84 and 10% of people score above 84.